Greetings, everyone. This is Andrew McDonald from the PAC Next team. Very happy to be your moderator today. And I can see lots of folks joining in as I speak. So we'll give everyone another minute or two to join in, and then we'll get started. Hello. If you're just joining in now, just waiting another minute, give it one more minute for folks to join in, take a seat, get a cup of coffee, and then we'll get going. All right, well, November greetings, everyone. It's great to have you with us today, tuning in from all over the world for our webinar today using life cycle analysis, LCA, and circularity to make comprehensive packaging decisions. My name is Andrew McDonald. I'm the project manager for PAC Next, PAC Global's program of sustainability and circularity initiatives. So before we get going, just a couple of important items. First up, PAC Global. So PAC Global is a nonprofit that provides a safe place for packaging leaders in the packaging community to collaborate, to innovate, to educate, and even to celebrate. And PAC Next is one way we do this. And so the PAC Next team, here we are before you, offers you a wealth of knowledge and resources related to packaging sustainability and circularity, especially through our education and training opportunities, some of which you see here. So in the next few weeks, we've got some great events, and I might add some of them are even live at the PACX event here in Toronto. So we're very excited about that, as well as our online circularity course at the end of the month. So for today, please note, as always, we will reserve some time after our presenters go ahead for Q&A. So find that Q&A button on your screen, and please, we welcome your questions. So go ahead, fill up that Q&A box. So without further ado, I'd like to introduce our two presenters today. First up, Alison Younts. Alison works as lead sustainability consultant at Trayak and is passionate about helping companies reduce their environmental impact and tell their sustainability stories. Alison earned her Bachelor of Science in Environmental Engineering at Ohio State University. Nathan McKee. Nathan is a sustainability analyst with Trayak and a graduate of the University of Cincinnati's honors program in environmental studies. Before joining the Trayak team, Nathan worked with the garment industry, focusing on lean production strategies and continuous improvement. And just before I turn the mic over to Alison, I just wanted to add that in past work at Ryerson University, I've had the opportunity to teach students the basic use of Compass. And so I'm very much looking forward to hearing about its newest iteration today. So without further ado, over to you, Alison.
Thank you, Andrew, for that lovely introduction, and thank you to PAC for inviting us to speak today. We're really excited to share more about life cycle assessment and our circularity calculation that can be done within our tool. So to start, first, a brief agenda. First, I'll talk about our company, Trayak, and kind of the vision that we have. Next, I'll go through life cycle assessment in relation to the Eco Impact Compass platform. I'll also mention our SCORE module, which allows visualization of trade-offs between sustainability attributes and life cycle assessment attributes. We'll spend most of our time today, of course, talking about circularity, how is this calculated, and some circular strategies evaluated with life cycle assessment. So Trayak's vision is we believe that all companies can design and manufacture their entire portfolio using sustainable strategies. And this really leads to the idea of mainstreaming sustainability. So rather than looking at sustainability as a one-off project or kind of as a siloed decision, we think about it as a comprehensive, holistic approach when it comes to product development as well as packaging design. Some services that Trayak offers is consulting and training. This can include case studies or packaging assessments to evaluate the environmental impact of a design change that a company is evaluating. We also offer expert services, sustainability workshops, as well as software automation and integration, as well as just our basic Compass platform. So that being said, I will turn it over to Nathan to talk more about life cycle assessment in connection with Eco Impact Compass.
Thank you, Allison. So why LCA? Why life cycle assessment? Well, as a brief background, LCA can help you calculate your environmental footprint. Eco Impact Compass specializes and is tailored in packaging and products. It also allows you to compare the impact of design changes, whether you're changing materials or formats. Track progress towards sustainability goals. A lot of corporations nowadays are creating external facing sustainability goals. And they're also creating CSR reports, corporate social responsibility reports. And LCA can empower that and support that with real data. Speaking of those CSR reports, KPMG's survey of sustainability reporting this year surveyed 5,200 companies, the top 100 companies by revenue of 52 countries. And in the United States, for example, in 2020, the top corporations are reporting some sustainability metrics 98% of the time. That's up from 92%. Now, Canada is also just about widespread sustainability reporting as well, up to 92%. And that was a big jump from the 84% just seen in 2017. In that same survey, Bill Murphy, the Canadian liaison at KPMG, had this to say: asset owners and institutional investors are now placing an increased focus on ESG, that's environmental social governance, by investees in evaluating their short and long-term portfolio strategies. This has had a direct effect on Canadian corporates, where the expectation to disclose some level of sustainability performance is now becoming the minimum required to remain competitive. Companies and stakeholders also agree that these initiatives are very important. The top two retailers, Amazon and Walmart, they're on board with this. Amazon, you may know, has the frustration-free packaging project or initiative, where they challenge their suppliers to create easy-to-open packaging that's 100% recyclable and to reduce packaging waste altogether. Walmart's Project Gigaton goes even further, and they're trying to avoid 1 billion metric tons of GHG emissions by 2030. And their 5 pillars, energy, nature, waste, packaging, and product use, goes beyond to push everything from reducing energy consumption at facilities, sustainable sourcing of material, reduce food waste, and beyond. And good data is also vital and is really what drives Eco-Impact Compass. So we have over 150 packaging materials and manufacturing and conversion processes. And our Compass methodology is reviewed regularly by third parties, and it was last reviewed June of this year. We also have special manufacturing, sales, and end-of-life regions. We have 9 regions, including Canada. Now, we use a cradle-to-grave approach in measuring the environmental impact. So that means of a product or a package, we take into consideration the material used, where it's sourced, how is it produced, manufactured, how is it transported, how is it distributed, the use phase in some cases, depending on what it is, and then the end of life. Is it landfilled, incinerated, etc.? Today, we also want to emphasize the cradle-to-cradle approach as we get into talking about circularity. Now, the cradle-to-cradle emphasizes the end-of-life area. As opposed to ending up in landfills, we're wanting to emphasize recycling, reduce, and increasing that useful lifespan as much as possible, and not allowing waste to end up landfilled and out of the system. So in Compass, we have 8 key indicators, and those are fossil fuel use, greenhouse gas emissions with and without carbon uptake, water use, human impact, mineral resource use, and freshwater eutrophication and ecotoxicity. Now, these are based on the standard and most important indicators that companies and industries use. And at the bottom, you can see an example of a bar chart that may come out of our software comparing 2 packaging designs, where again, it'll pull out the impact coming from material, manufacturing, transportation, and end-of-life areas. When you create an LCA, you're able to find the impact breakdowns for your primary, secondary, and tertiary package. That might mean your primary is a bottle that holds your product. It's secondary, maybe a corrugate shipper, and tertiary, which is at the pallet level. Also, company annual impact to roll all of that up to find your annual impact. And again, to compare the impact of design changes, which is very important to the day-to-day of a company.
We also have our additional module, Eco Impact Score. This really is a visualization of the different trade-offs or decisions that can be made between sustainability attributes and life cycle assessment attributes. So some of these could be, does my damage rate increase with my new design? Does the cost increase? Can I incorporate more PCR content, post-consumer recycled content specifically? And all of these attributes were developed in accordance with the Global Protocol on Packaging Sustainability. And essentially, we allow users of the SCORE tool to define these metrics and allow them to add them into their comparisons and decisions when they're evaluating these alternatives. So as I've said, they're mapped together to make a holistic decision. And some of these metrics can even be weighted based on a company's priorities to really evaluate the trade-offs that are meaningful to your designs. Some of those attributes, as I mentioned, are material waste, damage rate, packaging to product weight ratios, packaging recovery rates, and of course, the one that we are going to focus on today is the primary package material circularity index. So because you'll see a lot of these spider charts in the next part of our presentation, I just want to take some time to explain what we're looking at. If I'm comparing my rigid canister HDPE to a flexible bag, you can see that it's not always a clear-cut winner. But the way that I would read the spider web chart is the point closest to the center for that indicator represents the lower environmental impact or the best option. So for example, for greenhouse gas emissions, this flexible bag is closest to the center, so it would tell me that my greenhouse gas is less for my flexible bag than it would be for my HDPE canister. But this also tells me that my material waste for my flexible bag is higher than the HDPE canister. So that kind of gives you an idea of how we would read these charts. So going forward, they'll make a little bit more sense. So now I'm going to talk about calculating circularity. First, before we talk about how to calculate it, let's talk about what it is. So the Ellen MacArthur Foundation defines circularity as restorative by design and aims to keep products, components, and materials at their highest utility and value at all times. So this really kind of explains the pillars that go into circularity calculations and how we figure out if we are a circular package or if we need to make some changes to improve our circularity score. There's two different ways that we can calculate circularity. The first is the Circularity Indicators Project. This was primarily for product design or company-wide evaluation. The next, and this is what we use within the Compass platform, is the Material Circularity Index. This is a value between 0 and 1 that is calculated with higher values indicating higher circularity. And this Material Circularity Index is coming from the Ellen MacArthur Foundation's methodology. So as we're looking at circularity and kind of thinking about this overall topic, there's three different there's a mantra that comes into my mind, which is reduce, reuse, recycle. We've heard it forever, but what does it actually mean? So reduce is going to be the kind of first step in improving circularity. So we want to eliminate waste when and where possible, and ultimately use less material throughout our packaging designs or product implementations. The next option would be reuse. So that's the idea of designing products in a way that they are able to be captured at the end of life and reused in the same format. And the last option is recycling. And this is all about, am I designing something that doesn't have any contaminants, that is easily separated, or can be reliably collected to circulate these materials throughout the market and hopefully upcycle them rather than downcycle them. Now this leads into the idea that there are more materials that are circular or lend themselves to circular strategies better than others. Some of those materials are aluminum and glass. These materials are infinitely recyclable and makes them better candidates for circular strategies. Papers can lose strength during recycling, and plastics can become cloudy with incorporation of recycled content. We also, when we think about circular strategies, we need to have a method to recover and upcycle this material or use it in the same format for it to be truly circular. If we design a reuse scenario and we have no way of thinking about the supply chain or the logistics to get that packaging back to us to be able to be reused, then it's not a circular scenario. We also want to look at extending the useful life of the package whenever possible. So if we're able to increase that single-use container to 3 times use, we are improving our circularity. Also, increasing the recyclability and the recycled content can improve circular strategies. So now let's talk about how to actually measure the circularity index. So there's 3 different kind of collections of attributes that go into the circularity calculations. The first one is the input of our packaging. So are we using any recycled content or reused content? The next attribute is the utility or the useful life of this package. So by utility, I really mean how many times am I able to use this water bottle before I need to dispose of it. So increasing the useful life or the utility of the package really significantly improves circularity. The last category is recycling or reuse at end of life, or even composting at end of life. So any way that the waste is able to be kind of incorporated back into a useful product, such as a soil through composting, recycling into a new package, or reuse, of course, reusing that format as it is. Now, these circularity indicators are able to be used in conjunction with life cycle assessment, and some of the complementary impact indicators that we're focused on today are fossil fuel use, greenhouse gas emissions, and water use. And as I mentioned, those circularity indicators are coming from the Ellen MacArthur Foundation methodology, and the impact indicators are coming from the Compass methodology. So if we look at these together on the spider web chart, we can see that LCA attributes and circularity attributes sometimes move in the same direction, and sometimes they move in different directions. And I don't need to go into this in too much detail because we have scenarios that we will discuss, but I just want to show different values of MCI, Material Circularity Index, as in relation to the different LCA strategies that we have. And then this is just saying that we really like to look at LCA and circularity together to help us make better decisions. And you get an idea of the environmental impact as well as an idea of the overall circularity score.
All right. Next, we'll talk about moving towards circularity, and I'd like to start off with another Ellen MacArthur Foundation quote, and this is in their Upstream Innovation, a Guide to Packaging Solutions report, and their website is really chock full of information and great reports, and you could check that out. Now, it involves, this is talking about circularity, rethinking not just the packaging itself, but also the product and the broader business model, with the aim being to identify new ways of delivering value to users while designing out waste. In other words, circularity, and when we're creating these aspirational goals, they sometimes require creativity on our part and the ability to take a step back and take a look at the entire company without trying to hide from the impacts that you're creating. When we're talking about upstream versus downstream, what do we mean? So upstream innovation are those things that your company can do to reduce your impact. So you might ask, how can our company improve? Where can we leverage our impact? Which goals are most important? And which strategies will be the most effective for us? Although it's easy to point blame, oftentimes a company has a lot more power than they realize compared to an individual. And if we can leverage that, and if many companies do, we can actually get somewhere. But we don't want to leave down the downstream progress that is really necessary. So we can't leave that out. These are things like new sorting and recycling technologies, more robust markets for buying and selling that reused and recycled material, higher quality recycled content, free from those things that make it non-recyclable. What about accessible drop-off locations, more locations, and better collection infrastructure? And all of these things are more related to the infrastructure and things that a company ordinarily cannot as easily directly impact. A common and important theme that we're going to be talking about today is to avoid shifting the burden. When we're talking about avoiding shifting the burden, we're referring to environmental impact. Circularity is just one strategy towards sustainability, and no single score can tell the whole story because that impact is going to be holistic. That's why we have the 8 separate indicators. So when you're looking at your design decisions and your impact, you're going to want to compare multiple metrics to make those better decisions. Ask yourself questions like, does your business model perpetuate waste? What if your business is always going to produce single-use plastic? How can you change that? And what materials can be reused indefinitely, and how can you incorporate those? So as we go a little bit later into these design strategies, we're going to be thinking about how to avoid shifting the burden. These design strategies that you see before us, before you, these are all going to be worthwhile strategies to take a look at, sit down, and ponder over. These are things like improving your recyclability, component elimination and lightweighting, creating how to recycle labeling, how to inform the customer of your recycling initiatives. As you can see, it's a pretty long list. And as I said, it is worthwhile to take a look at each of them. Today, we're going to focus on examples for the ones that are in bold now. Component elimination lightweighting, material change, recycled content, and designing for reuse and refill. We're going to start to get into those examples. First up is going to be component elimination and lightweighting. So one might ask themselves, how can I optimize design? How can I reduce that waste before it's even out in the world? Which components can be fully eliminated, and can I lightweight anything? This example is going to relate to a CD case. So we'll have one CD case made of plastic with a paper insert. And then we're going to compare that to one without an insert, with no paper insert. Instead, you may have a QR code and a link to your website and a 10% decrease in material weight on that plastic. So right off the bat, when we model, we're going to get one of these spider charts, and you'll be seeing many of these today. So in red, we have the CD in its natural state with the paper insert, just as it was. But by eliminating that paper insert, which may have been used at your company for years and years, but what if you got rid of that and had that plus 10% lightweight? So as you can see, elimination just right off the bat decreases all of your indicators just about in equal amounts. And that kind of makes sense because you're simply removing material. When we add in some of these score attributes, we get a different picture as well. So we see this primary package MCI. In this case, it's giving us a plus 5% increase in MCI. But what about your damage rate? In this hypothetical scenario, changing your packaging could increase your damage rate. And that's going to be important for you to consider as well. Along with that weight reduction, maybe it's slightly smaller, but the theme you're going to see is that every single strategy has pros and cons. Let's say we did make that change. Over 1 million CD cases without that insert and lightweighted, 1 million, maybe that's your annual sales. You could reduce the equivalent of 68 barrels of oil over 248,000 average showers. That's a lot. And the equivalent of 941 tree seedlings grown for 10 years, like the carbon sequestration from that planting. And then some benefits, emphasizing these pros and cons. You're going to reduce your packaging waste overall and the weight, which could decrease transportation related impacts as well with that reduced weight. It could also reduce your cost of components, but it could increase your cost of components as well, depending on how you negotiate that with your manufacturer. Damage rate may increase. Maybe there's a change in the efficacy of your marketing. How important is that insert? How important is what you eliminate? And will the product integrity be changed? Of course, you want to continue to deliver the same type of product, and that's important to consider as well. Our next example, using aluminum and glass. You may have heard plastic-free, reducing and eliminating plastic. And is that going to be good for your company? Certainly, as we mentioned, aluminum and glass are going to be basically infinitely recyclable. So as you look into this, we may ask, which materials work for me? How will this affect my product? And how will my manufacturing process change? In this example, we have 3 containers. One's PET plastic, and then we're going to compare that to aluminum can and a glass bottle, all with the 16-ounce size. After we model that in Compass, we're going to see this, again, the good old spider chart. And these results may not be what you expect. In green, that's the glass bottle, and that's hitting as the largest environmental impact of several of the indicators. So that's on the outer edge, and the aluminum can is impactful in human impact and freshwater eutrophication, for example. In these two materials, a lot of this impact comes from the sourcing, how these materials are produced and mined. And then in the middle, you see the plastic PET bottle. It's kind of looking good right there in the middle. Aluminum can, and especially with the glass bottle, another thing to consider is the weight. That's also an important factor. Then incorporating the score attributes, you see an increase in the MCI for the glass and aluminum. But it's not so clear cut. And so when you create these strategies or when you model these strategies, it's important to speak with your colleagues and figure out what's important to your company.
Hey, Nathan, Andrew here. Just a quick question, just to help the audience understand what you're explaining. The question is, can you remind us what the score scale on the spider web graph means? So I think that the numbers right on the 20, 40, 60, 80, 100, what does that mean?
Right, that's a great call out, great question. So in this example and in these examples today, this scale is a relative scale for most of the indicators except for the MCI. So MCI is going to be a 0 to 1 basically, but the other ones are a relative scale showing you how they compare to each other. Of course, in Compass, you can have the regular values and you have all the data available to you, but for our hypotheticals, we're trying to focus in on the relative impact, but good question.
Yeah, perfect. Thank you.
So we'll go one step deeper with this example. And what if we have a situation where we want to incorporate reuse? So for this, we have an example where we have 2 uses and 5 uses with that glass bottle. And let's imagine that's with a store drop-off. So we have these same indicators, again, that relative scale. And right off the bat, you see the glass bottle with reuse times 2 and times 5. That's getting down to the environmental reduction we're looking for. Now, an important factor to consider is going to be transportation costs to bring it back and forth. Then we'll go ahead and look at the score attributes as well. We have huge gains in the MCIs, talking about overall circularity. And again, it is worthwhile to speak to your colleagues, figure out which score attributes are most important to make that decision. But as we can see, there's pros and cons to each strategy. Then over that same 1 million scenario, it could be the equivalent of taking 22 cars off the road a year, let's say, or 12 million gallons of water. And then again, to emphasize the benefits and limitations, benefits, you're going to result in less packaging, possibly stronger packaging depending on the material, and increasing the useful lifespan by a lot. Limitations, you need infrastructure to effectively collect and refill your packages. What about the cleaning cycle and the transport back and forth? And finally, the initial package may certainly be more intensive, especially when you're talking about reuse and refill. You're going to have to beef up that package to be able to have that increased lifespan.
I'm going to talk about a refill scenario. So this would be a scenario in which you rely on the consumer to purchase a bulk refill format. So really the first question is, will your consumers participate in the refill? Will they reliably purchase this new bulk package, or will the refill just not be used? And then, of course, what logistics do I need to consider in terms of selling these products together to add more value to the consumer and their purchase decision? And also, how is this packaging going to be handled within end-of-life schemes, as well as just on-store, in-store shelving? So the refill scenario that we're looking at is a soap dispenser. We'll look at a single-use example. So this is just one soap dispenser of 250 milliliters of soap. The refill scenario then uses the single soap dispenser and then has a refill pouch. And this refill pouch has 1,000 milliliters of product. So essentially, if I were looking at comparing these two scenarios, I would need 5 of my single soap dispenser compared to 1 soap dispenser plus my refill pouch. So looking at the LCA, you can see that my refill scenario does significantly improve my LCA impact. You can see again, like Nathan said, this is a relative contribution. So along the outside of my spiderweb chart, this is the single soap dispenser. And then you can see the refill scenario is plotted closest to the center, and you can see that it's pretty significantly less impactful. And this would then tell you that this is a good design change if the logistics would work. But let's add in those other score attributes, including circularity. So that's what the MCI is saying. And I can see that my LCA is, of course, still better. But now if I look at my MCI, the refill scenario does improve significantly. So my original score was about 0.2 for my circularity. And with the refill scenario, I've increased that to 0.8. So if you were looking at the other scenarios that Nathan talked about in material changes, those material changes did improve circularity because maybe you could incorporate more recycling at end of life or more PCR content, recycled content. But the utility of the package drives the circularity more significantly than the recycling or the reuse at the end of life. So because I have a refill scenario that I'm able to only purchase one of the soap dispenser and one of the pouch, my circularity score increases by about 316%. But I have to worry about some trade-offs with this design, which is my recovery rate. So I noticed that the refill pouch is some composite, flexible film that cannot be easily separated, and so most likely will have to go to a landfill or be incinerated and will not be able to be recycled. Now, of course, companies are working on recyclable films, so this could become a non-concern, but right now in my current scenario, you can see that my recovery rate does worsen with my refill scenario. But if we want to talk about the LCA results and the benefit that we can see from this change, if I were to switch from 1 million of my soap dispensers to my refill scenario, I would save the equivalent amount of greenhouse gas emissions as taking 38 cars off the road for a year. The water would be able to fill 28 Olympic-sized swimming pools, and the fossil fuel use saved could power 97 average homes yearly. Of course, with every decision, there's always some benefits and some limitations with these scenarios. So with the refill, we probably will reduce the overall packaging required for the same amount of product. And of course, we are increasing the useful life of the package, which helps our circularity significantly, as well as helps reduce the environmental impact over the entire life cycle. Now, some limitations for this scenario are, as I mentioned before, it relies on the consumer to purchase the refill format. And if a refill package is much heavier, it could take a significant amount of refills to reach a break-even environmental impact. So in terms of thinking about the average consumer, is it realistic for them to purchase 10 of these refills, 20 of these refills, etc.? So the next strategy is incorporating recycled content. The first question is, can recycled content meet my aesthetic requirements? Is there enough supply to meet the demand? And will it increase the price of my product? So I'm looking at a PET bottle with 100% virgin material and a 50% post-consumer recycled content PET bottle. If I'm looking at the LCA, you can see that my impacts are reduced across all of my indicators. And then if I add on score, then we can see that our MCI, or our Material Circularity Index, does improve by about 94%. So we are improving that because we're incorporating PCR content. But you can see that my total cost of my packaging is now higher. Now, of course, this is a hypothetical scenario, but we do know that PCR content can sometimes be more expensive than the virgin polymer. So that is just a trade-off that would have to be evaluated with this design change. Again, the LCA results, we see very significant benefits if we incorporate just 50% of the PCR. And then some benefits and limitations for this scenario are recycled content most likely will reduce environmental impact. You're increasing the demand and hopefully the market value of that recycled content, and you're improving the circularity. But the supply of the reusable recycled content is not always able to satisfy the current demand, and you have to find a sweet spot between PCR and strength and aesthetic of the packaging. Okay, so that was a lot to cover in about 45 minutes, but let's kind of focus on some key takeaways. So circularity is really one goal towards overall sustainability when you're looking at packaging design. Life cycle assessment can really help you show the data behind your impact and evaluate these design changes on a level playing field where you're getting the science-based methodologies and approaches behind the impacts. And then, of course, we do encourage looking at circularity and life cycle assessment together to evaluate the bigger picture, because sometimes they'll move in the same direction and sometimes they'll move in different directions. And of course, avoid shifting the burden from one area to the other. When you're evaluating any packaging designs, make sure you're taking a holistic approach when you're looking at this. All right, so that brings us to the end of the webinar, and I would like to open it up for questions.
Yeah, great job, Allison and Nathan. A lot of, complicated information to try to convey in a short time, and I think you did really well. And we have lots of good questions, so let's get to it. We're going to go back to the CD case example to start. So I think that was one of your first examples. And Nathan, I think it's when you were speaking, you gave the example of when it was the example of when you removed the item from the example and then extrapolated to, well, if you had 1 million of these units over a year, this is what would happen. And forgive me, whether it's CD case or not, this is the question, is around, does the tool automatically calculate those 1 million unit scenarios and then the corresponding benefits and limitations?
Right, great question. In Compass, you can choose any quantity you'd like. In this today, we chose 1 million because it's best to imagine maybe, yearly volume, because that's where you see the real impact as opposed to 0.000 XY, barrels of oil. So we just use 1 million for the sake of presentation, but you can choose any quantity you want. You can also choose quantities not only of your primary package, but maybe of your secondary. Maybe you want to do 1 million cases, 1 million pallets. That's all up to you, and it'll calculate the impact. On the CD case, I also saw a question about the QR code. Is the impact of the digital info, I'm understanding that as maybe the internet usage, maybe the electricity used, that is not calculated. We simply calculate the things directly related to the product or package. And then also a question about the ink and the printing process. That is included, and that is something that Compass can capture. Normally, the big majority of the time, by far the largest impact is going to come from your materials, and printing process is usually pretty minuscule.
Yeah, that seems to be consistent across the board from what I've seen too. Okay, thanks, Nathan. Perfect. We flagged, I think, all the questions on that, the CD case example. We've got a question about glass. So you brought up glass, and the question is did glass show up higher on the material waste side because it's not recycled enough, or because the recycling of it is material intensive? Can you just comment on why that seems to be high, the waste part of the glass process? I don't know if, Allison, that's something you'd like to comment on?
Sure. Yeah. So it is important to note that we are just kind of using hypothetical examples. Our understanding of the material waste was really that we expect glass to be broken more often than aluminum or plastic. So overall in the supply chain, there might be more material waste with making glass bottles versus aluminum. Now, naturally, we're not in the factory. We're not seeing, what is the actual waste. It was just a key point that we wanted to kind of call out within the score metrics.
Okay, fair enough. Yeah, good caveat there, but also a good question in trying to square, your comments about your observation that glass is infinitely recyclable, and then on the other hand, okay, well, there's potentially considerable waste as the process unfolds. And somebody who could potentially elaborate on that exact process is on the webinar with us from the perspective of a MRF. And so I'm going to go to that question. So separate question is, and it's a two-parter here, how does the model factor in regionality issues in one, the recycling infrastructure, so and then second, the reuse infrastructure? And so my memory from early in the presentation is you talked about 9 different regions, Canada being one of them. And I believe those relate to your end of life scenarios as well. But the point here is that MRFs vary even down within a city in terms of their efficiencies and capabilities and so on. So does the model take into consideration that part of the equation? And then part 2 is around reuse infrastructure. So for example, the distances traveled and the transportation required for those reverse logistics?
Definitely great questions. I'll start with the end of life scenarios. So in all the examples that we shared today, we are using the United States percentages, and those are pulled from the Environmental Protection Agency's report. I think the latest numbers are from 2018. So essentially it says, what is the likelihood that this packaging type of this material will be recycled, landfilled, and incinerated? And those percentages are used to calculate the end of life phase of the life cycle assessment that you saw. For Canada, we do have percentages based on the overall country. But if you did have like a specific MRF that you wanted to evaluate, you could change the end of life percentages to improve recycling, to change incineration, or even composting can be considered. And then for the reuse scenarios, we are working currently on improving the functionality within the tool of modeling reuse. We know that return rate isn't always 100%, so we need to include that as kind of a field that the company would expect, because naturally, if you're not receiving all of the reusable packages, then you do have to incorporate more back into the market, which would increase the environmental impact. So that is something we're actively working on. Right now, it's kind of assuming a one-to-one replacement. So that is another caveat with these results for the environmental impacts.
Okay, well, listen, good to hear you're working on including that field, because bang on that's an important one, the return rate on the reuse side. And then if I think if I understand right, on the recycling side, your comment there about the infrastructure, so one can begin with those, call them default assumptions, say from a broad region like Canada, but then the tool can accommodate customization at different levels.
Yes.
Yeah, got it. Okay, good. So here's one for you with regards to upcycling and downcycling. So does the MCI, does the Material Circularity Index differentiate between upcycling and downcycling in its calculations?
It does not. And that is another kind of distinction between circularity and LCA. So because we kind of just have an assumption that if it's recycled, it goes through the recycling process, but we don't have a split between upcycling and downcycling.
Okay, yeah, that would be quite an undertaking for sure. Good question, but yeah, we understand the tool for now that's not in scope.
Yes.
Fair enough. So shifting gears, on one of the slides, you made reference to the Global Protocol on Packaging Sustainability. So some audience members may be familiar with that, others not. So could you, very briefly just give that some context? What is that? And can you give some examples of what from that protocol is incorporated into the tool? Are they, the question includes, are the attributes and life cycle indicators, or is it more than that?
Yes, so the Global Protocol on Packaging Sustainability is more informing the score attributes rather than the LCA attributes. So the protocol is essentially a large report which goes through packaging sustainability strategies as well as attributes that can be tracked. So the definitions of the score attributes are directly pulled from that protocol. It essentially says, we should track damage rate, we should track cost, packaging to product weight, material waste, etc. So that's where that protocol is being referenced in our tool. The LCA attributes, actually, the tool was originally created by the Sustainable Packaging Coalition, and a group of LCA professionals, educators, everyone got together to define the attributes that really help calculate what is a sustainable package. So those indicators are, fossil fuels, water use, greenhouse gas emissions. They're very familiar to the LCA community. And those are not really informed from the global protocol, but I imagine they probably mention some of those attributes as well.
Well, okay. Well, I hope that addresses the question for our audience member. That certainly clarified some things for me. That was a good bit of background on, how the tool has come to fruition, some of the key sources for the tool. So on reuse, so a question about reuse, and so you gave a couple of examples that link to reuse, refill. Oh, and by the way, thanks everyone for doing the poll. We appreciate it. So on reuse and refill, is there anything that companies often just forget about when considering reuse and the impacts associated with reuse and or refill systems? Nathan, I hope you can, if you'd like to jump in on this one, that'd be great.
Yes, I'd like to. Of course, reuse and refill, these are big aspirational goals and strategies that companies can and should look into. Right now, there are, few companies doing it because it takes a lot related to infrastructure, the collecting of things. So in a reuse, for example, transportation costs and impacts are often forgotten because, of course, you have to factor in shipping it out the first time and then collecting it, refilling it, which also includes washing it, and then sending it back out several times. Depending on now the transportation mileage, for example, that can all be factored into Compass, but certainly that could be a substantial impact. And in fact, you may have to consider how many times do I need to reuse the package in order to get that break-even point and then see those environmental reductions.
Yeah, good one. I'm glad that question was asked, and having looked at lots of LCAs on reuse, yeah, absolutely. There are a lot of different parameters that go into figuring out where is that break even, and you've done a great job of articulating some of the most important ones. Here's one just going back to almost the basics of Compass and evaluating the impacts of a package and what are my options. So the question is, what if I only need to model my primary package? Is it possible to just focus on that and then separate out secondary and or tertiary packaging?
Yeah, another great question. The great thing about Compass is that you don't need a lot of data to start your analysis, and you don't have to be an advanced user or someone who's an engineer or a design specialist to do the calculations or, the modeling either. So of course you can easily just model the primary, and you don't have to think beyond that. However, We do say that the best practice is to design with primary, secondary, and tertiary in mind. And in fact, it's at the design phase level where you're going to have most of your impact. Of course, it's best to reduce and optimize your design before it gets out onto the production floor. And you have the largest amount of leeway to design your whole packaging system at that level. Also, if you don't have the data, you can still create those analyses. So damage rate, any of the score attributes, you don't need those things. Oftentimes, sustainability initiatives are things measured in years, of course, not months or weeks. So you may be thinking about, 5 years down the line or 10 years. So as you grow, as your information grows, the tool can capture that, but you don't need it.
Okay, good. And sort of building on that, just another clarification question. And that is simply, can one use Eco-Impact Compass, so the core Compass tool, if the whole idea of the MCI, the Material Circularity Index, and that is, we're just not ready for that yet. Is it, again, possible to parse the two out and just focus on those core, the 8 impact categories and just develop an assessment focused on those?
Yeah, absolutely. It's the same story. You don't need the information, but whenever you get it, or if you'd like to do it in the future, it's there for you. But again, sustainability and these initiatives, they involve so many different departments or so many different stakeholders, the logistics of it all. So if it seems like you're not ready for that, it's best to start with something small and go from there.
Got it. Good. Well, listen, before I forget, there's a question, just more of a practical question about today's webinar, and I just don't want to miss out on this. And the question is simply, will the webinar be available after the session? And so just want to say that, yes, indeed, PAC will be sending out to all webinar registrants a recording of today's webinar, in addition to a set of key takeaways that we prepare for you. So typically we get that out in 1 to 2 business days following the webinar. So keep your eye on your inbox for that. And thanks for that question and giving me the chance to clarify it. So listen, Nathan and Allison, we've exhausted the questions for today at this point, and we're just a couple of minutes before the hour. So I want to take this chance to thank you both very much for a well-prepared, really informative discussion. We had a number of comments in the chat just saying, thanks very much. This is really helpful. So on behalf of the PAC team, thanks to you both and to our webinar audience. Once again, we love joining you for these Wednesday noontime sessions on a variety of topics related to packaging sustainability and circularity. We certainly hope you'll continue to join us. We've got lots more in the hopper. And so on behalf of the PAC Global team, I just want to wish you all well. I hope everyone is staying as healthy and safe as possible. So keep smiling, stay safe, and onwards and upwards. We'll look forward to seeing you again soon.